Good morning. So I'm Mariam Al-Hanai, and it's my pleasure on behalf of Staff Development Committee and Math Club at Information Technology Department in Utah, Muscat, to welcome you all. We would like to welcome you to today's seminar, which is on machine learning performance evaluation, its measures and terminologies. We are honored to have Dr. Mohammed Khubaib Siddiqui with us today. Dr. Siddiqui obtained his PhD in brain data mining for epileptic seizures. He has around 15 years of industry research and teaching experience. He is also a member of the Australian Computer Society since 2019 and as well as IEEE. His research interest focuses on artificial intelligence, deep learning, and machine learning. So before I hand over to Dr. Siddiqui, I would like to ask our audience to post their questions in the chat box, and later on they will be forwarded and answered toward the end of the seminar. So let us start today's seminar. Dr. Siddiqui, the floor is yours.
Yeah, hi everyone. Thank you, Dr. Mariam, for nice introduction, and thanks to the faculty and college for inviting me for this talk. And actually, the reason for selecting this talk is very, very important because today's era is the era of machine learning, artificial intelligence, data science, deep learning. So whenever we talk about these techniques, so we must know actually what's happening and how we evaluate our model, how we train our model, how we test our model, what are the parameters. Because when I started my career in the machine learning and data science is 2009, early ages, at that moment, I personally felt a lot of struggle while understanding these terminologies, because what happens, heaps of algorithms are available. When we see the data set, heaps of algorithm available, okay, fine, we apply the algorithms, but we don't know exactly how to measure the algorithm, whether it's performing well or not. We just go blindly on the numeric values, 90%, 95% or 80%, but we get confused between training, between testing, what is accuracy, precision, recall, XYZ, and which measure is very important and which measure is not important. So based on the business scenario, we have to look for that. So in general, what happens, any algorithm or any model, if we talk about the model, so either there is two conditions, whether it's outperforming or it's not performing well. So the whole talk is based on this, the agenda of this talk. Yeah, so now what happens, the accuracy, we say that the model is performing well, the accuracy, but question comes, sometimes the accuracy is not, it's not important for that specific case scenario. And sometimes, sensitivity is not very important. Sometimes the specificity is very important. So those things we will talk. Now coming to the point, this talk, machine learning itself is a very, very wide topic. Day by day, new researchers are coming. So I'm not going to cover all of every aspect of the machine learning. I'm just going on the supervised, and in supervised also a classification method. What happened in machine learning, when the data set comes to us, so we see the data set, and there are two things in that. It's a column and rows, as we see if it is a tabular data set, and if the target is provided in that, very simple, what exactly the machine supervised data set, if the target attribute is provided, like here you see the very simple, I have taken the data set, and it is targeting that whether the customer will return the loan to the bank or not, yes or no. The true. So this attribute is known as the class attribute. In machine learning terminology, we say the class attribute, and all these are the non-class attribute. So when the input comes, so there are two possible values in the binary classification, either yes or no, or whether XYZ, for example, in the medical terminology, we said COVID, non-COVID, XYZ. So either it will be the positive or either it will be negative. So this is a simple data set, and that is describing what exactly the supervised machine learning. And if this column, the last column, is missing, if you don't know the means target, then it's unsupervised learning. So we are not going to talk about that. And one more thing, let me clarify that in the class, this data set is classified as yes or no. So distinct value, and the target attribute holds categorical values. So it's a classification based, because it's not a regression based, because the target attribute is not in terms of continuous values. So that's why we will put this data set in the classification category. Those who are aware about the SQL queries, so if you fire a query on this, select column name, distinct column name from table, for example, let's say, so only two values will come, distinct two value will come out of the million record, whatever the number count of the data. So this is a basic concept of supervised machine learning. Sorry. So what are the key components of the supervised data set? So there are the two key components of the supervised data set, the predictors and the non-predictor. So the predictors that are called as the non-class attributes, because in that we need to identify mathematically or statistically the different measures, like for example, if we are building the decision tree or the random forest or whatever, or the support vector machine. So let's say example of decision tree I'm taking. So we need to identify the correlationship between these attributes based on entropy, information gain, gain index, whatever, and then we decide. So these are the very, very important attributes. Based on that, we identify which one is the root attribute of that decision tree, and then the child will come, leaves. Ultimately, the result will come on the leaf. So, and the class attribute that I discussed in the previous attribute, the splitting ratio will appear based on that class attribute. So these two are the very, very important attribute for the supervised data set. Now, this is okay, it's fine. We have these two, it's fine. But the thing is that what happens next? So if the data set we have, and the data set itself telling that that target attribute, then training and testing, these are two very confusing words and very simple, but sometimes the researchers or the data scientists get confused in these two terminologies. So or when we check our data or check our algorithm, the classifier initially first go for the training data set that have the desired class attributes or the target attributes. Furthermore, we go for the tester. So for example, if you see this data set in the figure, the first table is telling that it's a training data set, because the class attribute is present, yes or no, classes are there. Once we apply our classifier, so classifier is telling the accuracy will come or whatever the measures, performance evaluation measures will come on the training data set. But when we go on the testing data and on the testing data, so we will remove the class attribute value and we will hide it, and then we test our classifier. Okay, now that's why its name is testing, at how our classifier performs well. Now the question is, if in one round does our classifier will be able to produce a good accuracy, or we trust that it's fine, or we need to go for the multiple round. Now, the scientists produced a method that is called the n-fold cross validation. So majorly in most of the work we use 10 CV, means 10-fold. For example, pictorially, if we go here, it is telling me that if we, in first round, we will hide this value for this data, and 90% will be appear as a training 90 attribute. Sorry, I mean to say that 9 records and 1 record will be the testing. Here, the target attribute, the no will be the missing from this. So this will be the first round. In the second iteration, this will appear as a class attribute and the value will be provided, but the second row, in that the target value will be the missing. Similarly, the 10 iteration will go one by one. Like here I have the more visualized, this figure is telling in the K1, in the fold 1, this one will be the testing. The no data and the remaining will be the testing. So 10 times when it will happen. So accumulation of all these accuracy of this one and all 10, then we'll club up and we say that okay, this whether this model performing well or not. So this is what it's. There is no hard and fast rule. One more thing, there is no hard and fast rule that you must take 90% training, 10% testing, or you can go for the 80-20, 70-30, but majorly scientists and researchers used to prefer the 90-10 ratio. And the thing is that one more thing, I just that's my personal experience that what I'm trying to share here. How we in our real life, how we say that our mind is also like a machine learning classifier. We train that's what we do in like the example of Sophie, what the Google introduced. So in the robots, so they train the machine in that way that the machine is taking the decision by their own. So very clear example. Hope everyone passed through this example when the GPS was not in our mobile, and we need to reach from our home to our university. So someone said that okay, from the first left, when you go to the state from the roundabout, take the first left, and another roundabout will appear. Then from there you need to go straight, and then the third roundabout you need to take right, and there will be the bridge will appear, and under the bridge you need to go like that. Initially, first 2-3 days or 5 days, it depends on your brain. Like your brain is like a machine learning, like that classifier. It depends on your brain capability, whether you adapt this thing in 2 days or 3 days or 5 days. What will happen in initial days? You will be very, very conscious to understand. Okay, I shouldn't miss any roundabout. I shouldn't miss any left turn. I shouldn't take any wrong turn where it is a right. I must take the right. I don't need to take the left. Wherever the right is required, take the right, not the left, like that. But after 5 days, and you will not think anything other than this while traveling from your home to your university. But after that, what will happen when you are habituated after 5 days? So maybe you are thinking about your home, or about your assignment, or about your job, or how to meet your professor, what we need to discuss. So you are just going, and automatically your car steering will take the right or take the left, and ultimately you will reach your destination. This is what previously till 5 days it was the training, and after that it was the testing. So this is what I personally am telling. I think maybe you can take another example, but this is what I have taken example to explain what exactly the difference between the training and testing. So this is what. Coming to the point, there is a fight that if the positive value is predicted as a positive and the negative value is predicted as a negative, then there is no fight. So what is exactly why we evaluate the classifier. So because the issue is that sometimes what happens, the positive value is not predicted as a positive, and the negative value is not predicted as a negative. That's why the whole fight is here of the classic. Based on that, we say that a support vector machine is not good, or a support vector machine is good for this data set but not good for the for another data set. So based on that, another scientists are producing leaps of algorithm, like decision tree. Initially Quinlan proposed, then Bremanley said that no, decision tree is not only sufficient, C4.5. They introduced a Bremanley from US, they proposed a random forest is very successful. CNN was very popular. Then the scientists said no, CNN is not good for the medical images, they are going for the capsule networks, blah blah blah. So all fight means, bottom line is that all fight is for the performance evaluation, performance evolution. This is the main theme. So that the example is that like I have given in my slide, that if the cancer patient is detected as a cancer, it's fine. Non-cancer is detected as a non-cancer, fine. But if the cancer patient is detected as a non-cancer, then it's a problem. Okay, very big problem. And if a non-cancer is detected as a cancer, then it's a problem, but not much, only financial hurdles will come. So this is basically the fight starts from here. So the four major outcomes of any classifier, if we understand these terminologies, then there will be no issue for understanding and selecting the outcomes and the results of our algorithm, whether they are producing good or not, and for a dedicated solution and for a dedicated business problem. So one is a true positive, another true negative, false positive, false negative. That's it, only four. So for that, true positive and true negative are very kind of easy to understand, but the issue comes for the false positive and false negative. That's my personal understanding, and what I face hurdles. Most of the people, they do face hurdles in that. So true positive, the positive prediction is the true positive and the false positive, and the negative is that true negative, false negative. Now I'm going to explain in the next slide what exactly does mean that true positive and these four terminologies. So true positive, for example, if someone in a Boolean algebra, like Boolean, we are aware about that Boolean, like if one is one, then it's true. If one so for example, if someone is COVID patient and we are detecting or predicting him as a COVID also, then that means it's a true positive. And non-COVID, we are predicting as a non-COVID, then it's a true negative. So, but the problem here, false positive and false negative. False positive means, notice the here to understand positive. False positive means originally it was the negative, but our classifier making a mistake and telling that the error is that telling that this guy or this guy have COVID, but it does not have a COVID. So whatever example, just I'm taking an example, means the result was true. Actually it was true, but our result was telling the result was false, but actually the result was telling the truth. It was negative, but it was telling to the positive. That was the false positive. So incorrect prediction. Here notice these two lines. Incorrect prediction, that's fine. Incorrect prediction, okay, but incorrect positive prediction, so it means it was a negative, but our classifier estimating it as a positive and putting it in a positive category, although it was not. So for example, if you know, like I've taken a just example that when the classifier detect a normal customer as a defaulter, so it was not like that. Or another example, in the medical scenario, you can take that a person who is in non-COVID and you are taking him as a COVID like that. So that is a scenario. False negative, incorrect prediction also, but initially it was a I mean to say that it was a positive, and it is telling that it is a negative. So when the classifier detect the person a kind of positive and telling him as a negative, so this is also kind of false means error. This is also kind of issue in this. So based on these four scenarios, a confusion matrix, that's why actually these two this is a main, and it's a n by n matrix. N by n means maybe in some cases the value will be the class value, distinct value will be more. So in that moment also it may vary. So here actually we put these values true positive in this in that scenario, like true positive, false negative, and false positive, true negative. Now here one more thing, what I found in some context or in some places, if this value actual value is given, then the putting the false positive and false negative will be like in this fashion, like true positive, under the true positive need the false positive will be provided, and the predict class will be like upper. But I found also when I was studying, in some examples it is predicted will be given here and actual is given here, then in that scenario false positive will go upside and the false negative will come downside. So if if the defaulter is predicted as a defaulter and 10, for example 10, so it's a true positive, and if a non-defaulter is means considered as a non-defaulter, then it is the I mean to say it's true negative, and the defaulter is a case of non-defaulter and it's a false negative, and non-defaulter is considered as a defaulter, then it's a false positive. So this is a main, and it plays a significant role. Means if this matrix someone understand, then it is very easy for him to take the decision for precision, recall, sensitivity, specificity, receiver of operating characteristics. All those measures that we are going to discuss in future slides. So what exactly the accuracy? Accuracy is very general word, and of course whatever we talk about for any new, for example, just during the COVID vaccination, so we are discussing the word accuracy. Okay, how much accurate is the Pfizer is? Okay, what about the COVID shield? How much? Okay, what is the accuracy for the? So this is very important, but in machine learning, this accuracy is not important every time. Generally, for example, if you see the formula, means if accuracy is the truly detecting the cases, those who are positive predicted as a positive, and negative predicted as a negative, and there is a no error. So for example, if let's say 5 positive and 5 negative, true positive, true negative, and also here also 5 out of 5 plus 5, and there will be no false prediction here. So automatically the accuracy will be 100%. But please read the second bullet point. What I'm trying to notice here, the higher the number of correct prediction made by our model, the higher the value of accuracy. Fine, but condition apply. It's good measure when the data is balanced. This is a very point to be noted, that in some scenario, our data is not balanced. At that moment, what happened? For a very basic example, I'm going to take person those who have a cancer, and not everyone have a cancer, like diabetes, blood pressure. It's very common these days. But may God protect to all of us from this disease, cancer. I'm taking this example. Out of, let's say, 1,000 patient, and every time the technician is testing, taking the cases, and 5 were the cancer, and remaining 995 are non-cancer. And in these, so this is a very highly imbalanced data set. One side is 995, another side is only 5. So what happened at that moment? The classifier get confused and do the and get highly skewed towards the majority class. Here the majority class is 995, means non-cancer, and the minority class is 5 cases, so that is a cancer. So what happened? They become skewed towards the majority class, and the accuracy will appear as 100%, or maybe around near about 100%, let's say. Not 100%. This example taking, even if we are missing one cancer patient as a non-cancer patient, so that is a big trouble for us in the real-time scenario. So in these cases, the accuracy is not only the measure for this. That's why for all these data set, we used to calculate other measures also, I'm going to for precision. So precision and accuracy. Precision also we heard a lot about in our generic language, and when we talk, okay, how precise is it when we talk? And okay, the thing is that very basic example I'm taking. Let's say there is a luggage, and the actual weight of a luggage is 5 kg, and we have taken the weight repeatedly 5 times. So actually the if 5 kg is appearing every 5 times, then it means it's 5 kg coming, and at every iteration it is coming. The actual weight, it means it's precise also, accurate and precise also. But if every time it is not, neither the weight is coming correct, nor the it is precise, so that means it's neither accurate nor precise. So what exactly here the figure is demonstrating that, for example, if one time it is it's neither precise nor, so there is no closeness of the result to each other. And if it is accurate, but it is if it is accurate, it is not precise. So the third one is precise also and accurate also. So this is the thing. And if, for example, if out of 100 predicted defaulter customers, 50 are really defaulter, then the precision will be 50% kind of. So the mathematically it can be calculated as true positive upon true positive plus false positive. Why this notice this point? False positive means it was not actually positive, and it was negative. So but classifier is telling us a false positive. So we have to focus here, and when we'll take the ratio of this and the percentage, then the precision is that. So what are the correct accurately means correct prediction is calculated through this precision. So this is this is about the precision. And another is the recall. Recall have 3 names. One is the recall, another one is the sensitivity, third one is the true positive rate. So recall is required when it is actually the result is positive, but our classifier is defining as a negative. So there is an error. So to calculate this, find the how often our results are correctly predicted. So then at that moment we have to calculate the recall or the sensitivity. So again, just a difference here between them. It's here we are taking the false positive, but here we are taking the false negative. One more thing, it is very important between the precision and recall that always both are not in a same boat. So if we increase the precision, then the recall will be decreased, and if you increase the recall, the precision will be decreased. So these two, this figure are defining that if precision is higher here, and the recall is less, and the recall is higher, the precision is less. The thing is that at that moment, if you require, sometimes we require the common value to present our model, that then the solution found by the scientists at F measure score, or some people say that F1 score also. So improving them, it's kind of taking the harmonic mean of these two value, where we calculate and we produce the result of both, because it is not exactly same that we rely on one and we need to neglect another one. Sometime just to present our model that okay, this is harmonic mean, that if it is greater, then and it is considering both the precision and recall, then we can proceed with it. But the story is not just story is not finishing here. There is some more things are need to be discussed. Specificity, it is very kind of interesting in a way that the data set, the data set of the ability to test the correctly identified that were means those correctly customer without any default, like, so it's a ratio of the there in the sensitivity. We are taking the ratio of the true positive divided by the true negative, sorry, true positive divided with true positive plus false of negative. But here specifically we are taking the different scenario that we need to take care of true negative value, negative value, and those who were actually negative, but our classifier were identified as a positive, the error. So combining these, the denominator of these two, and taking the true negative will be the considered as a specificity. For example, if the specificity is 100%, that means all the customer are the non-defaulter and the true negative. Just an example, you can vice versa example based on the business solution and the requirement. False positive. So if sensitivity and for sensitivity or true positive rate, whatever you can say or recall, the difference between the sensitivity is that it identify the how often model is correctly predict in the positive cases. For example, we have two in the, for example, yes cases, and false positive rate is that how often the model is correctly predicting the no case. So this is the false positive rate. So how often our model is predicting the false, means false cases, predicting that was the correct, actually means non-COVID patient, let's say, and how often our model is predicting without an error the correct cases in terms of non-COVID. So this is the scenario in the false positive rate. So the best false positive is always 0, whereas the worst is 1. So based on that, the like in the recall, sorry, in the F measure, we have taken the harmonic mean, or in the this we calculated the precision recall. So if we want to calculate between the false true positive rate and false positive rate, then there is a one solution proposed in 1971 during the war So in the military strategy, they use this ROC, receiver operating characteristics, for the signal detection and all. So that has been introduced in machine learning also, or to identify that what is the true positive rate and the false positive rate. If you want to consider a model that has considering the correct definition and the correct result of both the things, then we have to take care of both of them, not only true positive rate or not only the false positive rate. Sorry. So at that time, we need to calculate the area under the curve. So in ROC is a trade-off between the true positive rate and the false positive rate, and there is a one threshold value that like here it is a kind of the diagonal line. If the graph goes up beyond that, so the model is considering as a good model, and more closer to this one value, true positive rate, the model is more accurate in terms of that. But it is coming to down, then it is kind of not okay. So like the right side, that example of my research paper during the obesity analysis, that I found the graph is going up, and the area under curve is calculated at 0.809. So like that. So the values always comes between 0. Yeah. For example, if we are so the major issue is that in the thing is that the threshold value is not fixed, and we need to tune according to our requirement. So majorly we used to take the threshold at 0.5. If the curve goes up beyond 0.5, then we say that it's performing and reaching to the 1 point. But if it goes down, then it says that it's not performing well, and it's opposite to that. So this is also one of the measure of and very significant measures in that is used, and particularly when the data set of in the medical science. So most of the doctors use this measurement in the disease diagnosis. So there is an equation provided, a mathematical equation, how to calculate the area under curve. Those who are interested, they can research on this more. So exactly what happens in mathematics, so the area is calculated as it's a curve. So taking that section in the dividing the curve in a trapezoidal way. So for example, first they calculate this section, then further they calculate this section, and then all it continues in all the way, and the summation of all this curve get calculated. So this is an equation that I also have taken from one of the mathematician paper and put it in my paper. So this is the way how exactly the curve get calculated in this. So these are the research paper that I have worked on some of the future paper, but published around 27 articles in machine learning and data science. So I have taken these paper as a reference in order to make the slide and put it there. So this is all about the classifier evaluation, and thank you. If any questions, please.
Thank you, Dr. Muhammad, for this interesting seminar. Do we have any questions from our audience? Okay, Doctor, what made you like go into this kind of research?
So whenever we used to do the performance evaluation, so like in the first paper, like if you see the machine learning based novel because causal detection, so there it was actually a part of my PhD thesis also. So there I found that the data set was highly imbalanced, and At that time, I was going through only accuracy, and I was not quite mature researcher also, to be very honest. So when there I found the significance of the recall, and when I studied and how this much is very important, and we have done the undersampling and oversampling kind of thing, and introduce a cost-sensitive learning method algorithm. So there I found that the exact significance of this result. Similarly, in the obesity paper also, obesity research, we can correlate, and we found that the receiver operating characteristics to between the true positive rates and the false positive rate. So ultimately the goal is that we cannot rely on a single measure. So that's why I have taken, and this is not limited only. So there are other more parameters that are remaining, but I have taken these 5 or 6 evaluation parameters that are very commonly used. So if you go and study like this research paper, paper number 4, Lalkhan, when I was studying this in 2008, this paper was published, not very new. Even though they have done a lot of analysis and all these things, and introduce so many true positive rate and not true positive rate only, correctly predicted, and means pitfall, other parameter also. So this is not only limited, and but we have to again and again I'm telling that one sentence based on the business solution. Like in industry, we use the word business solution or business requirement. Based on that, we choose our classifier also, machine learning classifier, and based on that we choose our evaluation parameter also. For example, if the data set comes to us provided by the client, and we start working on the K-means algorithm in unsupervised learning, let's say, and although that K-means will not work there because of the inputting the value of clustering, how many clusters you want to generate, so that is not worthful. So, and there we need to apply the genetic algorithm, genetic clustering. Similarly, in the classification, the client want to see that what exactly the patterns are there if else condition, but we are not able to see those things, and we applied the support vector machine blindly because people said that support vector machine is very good, but we don't see the requirement, and we applied. So two things, I personally say that two things researchers, those who want to do the research in industry also, two things must know. Choosing the best classifier based on the data set and the requirement, and choosing the best performance evaluation parameters. Then we can do something worthful. If we have a data set and we have not studied carefully and the business requirement, or whatever the target of our research, what we want to achieve in that research, and we have blindly have taken the classifier, then there will be wastage of time, and we will that I did in my past, from my past experience I am doing. So if you see this second paper is based on the which performance will be best for the EEG signal data set, which classifier will not be best, and why it was not best. So this must know before doing that. And similarly, choosing the performance evaluation parameters. So these things, and if choosing the performance evaluation parameters, before that we must know about the confusion matrix, about the training data set, testing data set, how we do the 10-fold cross validation, why it is required, why only 10-fold is required, why not the 70-30 is required. Sometimes we have to take 95-5 5-fold cross validation. It all depends on the business requirement, data set, and based on the your machinery and all that, you have the resources you have. So it depends on those things in this. And if you have those who are the researchers, those who are in this meeting, I highly recommend that if you don't have these knowledge and you directly jump on in this coding of in the scikit using the scikit-learn and the PyTorch, Anaconda, using the applying, and you have good in Python and start applying the Python coding, all those things. I can say that very confidently, the result will not be worthful, and so you must be clear of all those things. Then you can do the coding and apply the existing classifiers, or you can build your own classifier based on the loopholes in the existing classifier.
Yes.
Any question?
Any question? I have one question, Doctor. I see that you are mainly applying the machine learning to the health sector. Like, are there any other sectors or industries that are really currently are involved with machine learning?
Machine learning. I personally, why I applied in the health sector, because I got some projects previously when I was in Saudi Arabia. So I got projects, funded projects on health data set department of health over there on diabetes, hypertension, and obesity. So the data was accessible, and it was a very problem there, blood pressure and hypertension over there. So based on that, I have taken this. And I was more inclined personally towards the health because the machine learning, the epilepsy, when I brain data mining, I have seen the patients though who struggled. Personally, I have seen the patient struggled during the neurological disorder and the fits or the stroke comes to them. So that I have personal attachment, and it was very hard to get the data set for these data set. Now coming to your point, I was not only limited only health. Yes, I do publish some articles in the intrusion detection also. There was one funded project I did in Saudi Arabia, intrusion detection. In that project, I have applied the unsupervised machine learning k-means using the Oracle data miner tool, and there I have done some analysis at which protocol is more exploited by the malicious attacker. So based on the cluster and Euclidean distance is involved in that. So we identified. Now coming your next answer, that which area will be more interested in future research. So see, health sector is always a burning topic, and it will not. It doesn't mean that if someone has done the research in health using data mining 10 years back, so it will see those who had done the research on COVID using machine learning and deep learning. If you see their citation, heaps of citation. Even I personally got for one paper 400 plus citation on COVID applying application of data deep learning. So similarly, I published 5 or 6 articles on COVID. So it's always a burning topic, and health requires still we have a lot of facility. Still, health sector require a lot of improvement. Coming another point, you can apply the machine learning and deep learning in the Sensex dataset, banking Sensex dataset, where you can predict what will be the market up and down, those things. This is one of the application there. If you are interested in the image analysis, there you have to study the image processing very well, feature extraction and all. So there you can apply the CNN and capsule network. That is a very emerging classifier is coming. A lot of work has not been done. Then you can apply in different, like you, for example, a car is over speeding and 120 plus. So how you will capture that image of a car or a number plate that it is over speeding or not. Or for example, trash detection in our oceans and our seas are, getting very dirty, and you need to identify through the deep learning, you can to identify the trashes in those so that the natural aquatic life don't get affected. So these are the application of these, yeah, and but not limited. Again, I will say that not limited. Based on the data set, but wherever you apply the availability of the data set is mandatory. If you want to apply, but the data set we don't have, so we can't do. So
thank you. I have a question here. Say, can machine learning algorithms be developed in teaching and learning domains? So have you come across this kind of research?
Yes. There is one research paper published in Web of Science journal, Computer and Electrical Engineering. There, during the this is also one of the burning topic at the moment, when the everything is not everything, most of the thing is coming online, and online teaching, e-learning. So, for example, if I'm giving the presentation and I'm as a host or giving the presentation, but the audience, I need to take that which student is more active in my talk and which student is not active in my talk, and which student is means mid. So how do I can do? So I need to recognize the face expression. So we have done the analysis on, but the data set was very small. It was only 25 records. Based on that, we have done. So whether it's there were the 5 expression: anger, happy, sad, like that. So analysis based on the 5 face reading. Every time the webcam is capturing the data from the users, from different user, and that data is coming to a central storage, and from there we have trained our model and test that whether it's this one is happy mode, or this one is not happy mode, like that. So this is one of the good example in education system where we can apply these things. Machine deep learning, particularly deep learning, because it will cover the image analysis. So the deep learning CNN and algorithm will work here, CNN and capsule network.
Okay, so I think we came to the end of our meeting today, our seminar. I hope that all our colleagues and audience enjoyed and got the best or the maximum knowledge. Thank you very much, Dr. Muhammad, for being with us here today. We really appreciate it. And we are looking forward to have you again with us here.
Sure. Thank you so much for inviting me, and I really very grateful to the department and to the Sultanate of Oman for inviting me in this talk. And yes, feel free in future, I will be happy to give presentation.
So thank you very much. Thanks all. Also, I would like to thank our audience for being here with us, and see you inshallah in the next seminars. Inshallah. Thank you very much. Enjoy the rest of the day.